Okay, folks, can you hear me okay?
Yep.
Oh,
Loud and clear.
yeah, that's great. Okay, so I've been looking over the material I've produced for David, and David and I had a chat yesterday to discuss how he would approach the core computing. And what he's trying to do is set out a kind of a process which has a structure. So hopefully it will support you and sort of get you to doing as well as you can with the literature review. And we talked about what I was doing and what I want to focus on, and I will record this. It's actually recording it, Zoom recording. Okay, so what I'd like to do is, and I'm just going to change my share parameters. Bear with me a second. I'm just going to concentrate on the visualizer. There we go. Okay, so you can see the visualizer window. Um, what I'm what I did was before this lecture is I went back through the material I provided and I looked at the video, which is called number 5, stage 3 analysis. It's absolutely critical. It's often the area that is students have the least experience. A lot of students know how to, whoa, what's going on here? I'm pressing all the wrong buttons on my window. Let's stop that. It's often a place where students have a vague idea. And I mean, what's evident to me is those students who studied English, history, maybe even archaeology, or those kind of subjects, humanities or social science subjects at A level or before they came here, tend to have developed quite strong analytical skills. Those who've come through to us normally from computing backgrounds, because your A levels might have a little bit and BTECs might have a little bit, but not as much as we really need to make this be useful to you and not be a struggle. So I've looked back at my video on that particular one. So this will complement that video. So it runs in a slightly different direction, but it picks out some points from it. So if you watch this after you watch the other one or watch it before, they should support each other and hopefully give you a clearer idea. So I'm going to approach this video in this way. Okay. Let me just write this on the thing. Okay, so whenever we're thinking about computing, we're thinking of computing as a subset of technology. Okay. And technology, of course, is everything from your basic devices to your TVs, your smart home stuff, you know, all the kind of stuff we discussed and people discussed, including autonomous cars and all that kind of stuff that we saw in that very first section of the core computing. That's all the technological stuff. What's interesting and really, really important is an analytical framework, a way to approach any analysis that you have for literature review, is that you always see it in a relationship with what we call human practices. Okay, so very briefly, human practices are basically things that human beings do. It's everything from our practices around education, our practices around business, how we conduct our business. They're all what we call human practices. And the word practice comes from the fact that it's basically all about human activity. But practice doesn't just mean activity. The crucial element of practice is that it is always social. It always implies a group of people, right? So you think about business, you think about the basic processes of eating, food. It always is in a field of human or social practices. So when you're trying to work out a framework, when you are given your literature review, some of the range of topics that David, he's going to vary them, but he's sticking quite closely to the kind of thing he did last year from the conversation. So I don't want to give too much away, but I don't think he'd be bothered if I did. One was about biometric systems. One, I think, was about training in cybersecurity. Those two I remember. But if you think about it, the basic gist was he'll give you a research topic, which will link, which will be about what looks like a technology. But actually, the really hidden element to every technology is its role and its place within our social and human practices. You can take anything and you can see that there is this reciprocal relationship between technology, in your case, computing technology, and human practices. When we think about advances in technology, we think about the impact they have on human practices, right? So what I'm trying to do is just enumerate these connections so you can see how natural the two concepts fit together. So when we think about cybersecurity is a fantastic basic category of technological and technologically related subject matter, but actually you cybersecurity folk are massively caught up with the issues of human practices, stealing, protecting companies, hacking. What's that thing called where you trick people by, I forget the name of it now, by sort of lying to them, not phishing scandals, but things like that, where the real hacks and the real cyber threats are to do with social things, not necessarily to do with just someone hacking a piece of technology. Someone will shout it out, I'm sure you will, if you know what I'm talking about. So the point is that these two things always go together. So whenever you're thinking about doing any analysis in this field of subject, right, it's always an advantage to ask yourself the pair question. So if you pick a technology, right, so David will put some technology or what looks like questions to do with training or other bits of development, always ask yourself that what's the human practices involved in it? And it's generally quite straightforward because most of you will instinctively know this, right? I mean, if we just take a mobile phone, we can see that as a lump of technology, right? And it so clearly has had a huge impact on human practices. In fact, many of the issues and technical issues to do with phones, their development, their security, is an issue to do with how we as human practices, our business practices, our social practices, are caught up with the issues that the technology itself throws open, right? So there's a natural fit. Nothing in that should, I hope, be a huge surprise to you. So this is a very simple and I think a useful way to frame it. And I can say that in that core computing first piece of work, that the video stuff, some of you instinctively spoke about your topic in this type of way. You may not have used this diagram, but you detected quite naturally the relationship that whenever we're dealing with tech, it isn't just about studying mathematics and algorithms and obscure scripting languages and interacting with bits of machinery. It is about social and human practices. And computing is probably the most significant thing about computing is that close relationship. Hence the popularity, I think, in that first video about has technology impacted human nature? Because human nature is clearly tied up with what we do, our practices. And so there's a natural reciprocal relationship in the way that people discussed it. Okay, so this is a good framing device. And how does it frame an analysis, right? You're given a particular topic. How can you actually use it? Well, let's kind of, if you want to speak, please feel free to ask a question along the way. But I am going to keep this quite short and hopefully open up a space for questions if you want to ask at the end. So how is that useful if I'm actually undertaking an analysis, right? I read an article, a specific article covering some specific issue, and you think, okay, this is too general, Nad. How can I actually exploit this in terms of, the literature review? Well, this is one really, really straightforward framework. Again, this is echoed from the other video. When you're looking at trying to do a basic analytical or a critical piece of writing, this is essentially your framework, right? And this is a repeat. It's also in the other video. So what does this little simple diagram mean? Some of you may remember I drew this. I doubt you will. In one of the early lectures, which is a bunch of symbols I use in the development of my own work. Because it captures, this is a subset of a much bigger set of problems. We'll keep that out of sight. So what does this mean? And how does it help me analyze the situation? Well, if you treat an article or you treat a particular development, right? There are two obvious things that you might want to look at. As a response to a problem set, then you've already entered the territory of analyzing what's going on in that article in development, right? This is the advantage of this type of approach, is that by treating something as a response to a problem set. So what do I mean by a problem set? I should spell it out in a sec. but it involves words like, a context or set of conditions, or an even easier word to get your head around is a situation, right? Technology creates a situation. So if I just bring it back to the general frame, technology creates a new situation for us. We adapt our practices, and it has this kind of reciprocal. New technological advances change a situation. Our situation impacts how we behave politically, socially, etc. Those changes then impact further developments of technology, and you notice this constant changing of situations and development. Situation may be an easier way to get your head around the idea of what a problem set is. So we need an example. So let's just say that the word biometric comes to mind, but if I use that example, I'm worried that everyone will spot it in David's list of questions and you'll all go for it. It isn't necessarily the most interesting topic, if I can say that. I did help him mark them last year, but it's a good case point. Actually, a better case point was quantum tech. Let's just talk about quantum tech or some of the stuff you did on nanotechnology, right? Those are really interesting technological developments and how they impact our social practices. But we're not interested when you do an analysis in a topic, right? So if you think, okay, yeah, that's an interesting topic, when I look at that research question for the literature review, and I'll do that because I'm interested in that topic. No, don't do that. Don't think of it like that. Ask yourself a simple question. What problems are involved which allowed this technology and this particular thing to arise as a response to dealing with these problems? They're not always solutions, but some of the responses to obviously solutions to social problems, to previous technological problems. Quantum computing is clearly a development which is both a response to previous developments in computer advancement and the impact that's had on all kinds of incalculable impact on a range of different social and institutional practices. But think, what is the problem set? Because what you need to try to do when you have a research question, a literature review question, is you need to see it as a response to some problem. You need to unpeel whatever the article, whatever the question is about, and try to reframe it in terms of what's the problem at the heart of this. Now, some research questions and some of the literature review topics that David will supply will be obvious and really easy because the problem will be built into the question. And so it suddenly seems a lot more straightforward how to tackle it. Now, the topic themselves may not initially attract you because you think it looks quite dull, right? But try to do the judgment based on how clearly you can analyze the situation, right? So this I would say is probably the most useful thing. When I teach a subject in computing and when I have to learn any new topic, I always approach it like this, right? You can throw an artificial intelligence problem at me, or you could throw an obscure problem in, say, okay, we've got a healthcare research group here. And when my colleagues talk to me about healthcare research, I'm not an expert in it, but I always analyze it in terms of seeing it as a response to a very specific set of problems. So I try to unpeel what they're talking about, and then it's easy to follow their line of reasoning. You don't have to be an expert to do it. And I find it really, really helpful. I'll give you a good example. I went to a research speech by one of our PhD students, and they were doing research on a subject which might interest some of you, microaggressions, right? I don't know if any of you have heard of that. It's a very big topic in politics and human practice. Basically a microaggression, if we come back to here a sec, a microaggression is all about the way that, say, someone treats you, but doesn't necessarily, it's not a big, I'm going to get a knife out and stab you type of aggressive act. It's one of those subtler ones where someone is quite rude, they snap, they do all this kind of smaller, and why do they do it? So anyway, this PhD funded research was about, it was quite complicated because it was related to the idea of microaggression, how people think that they've suffered a microaggression and the data that was collected. It was a real, I don't want to speak out of turn, but it was almost too complicated for their research because of the problem set, what they'd ended up doing, and you'll find this when you dig into research material, people end up with a problem set, cutting stuff out, shifting it out of the way, so they reduce the problem set to manageable size, then they propose a solution or a response to it. So what I'm trying to get at is that when you're trying to unpeel an article in order to analyze it, what I'm describing to you is an analytical process, right? In the 1600s, let's say broadly, the very famous French mathematician, I'll put it onto screen, hang on, called René Descartes. And he proposed an analytical method, which we still use. He was a mathematician, if you like, and an early scientist. And his method was literally this, right? And I'm just going to crudely give you an idea. And this is also valid, but there's a weakness in this method. And the method that I've suggested here is closer to scientific analytical thought as well. And as students in this discipline, you'll find this more useful or enhance it. Basically, the analytical method is, he said, was this. Imagine that field represents a problem, right? And you can apply this to anything. And you want to try to solve this problem, this large scale problem. What he basically said, and you will find this so obvious because you've inherited his idea through your schooling, is you break it down. You find the joints in this problem where the natural points it splits into smaller pieces, and you solve each of the smaller pieces. And that was what was called the analytical method. So it's taking a big complex question and breaking it down. So how would that apply to a particular question, research question that you might have? Well, the problem set may be huge. So you read an article, a journal article, and you think, well, it's talking about this, it's talking about that. How do I get my head around what it is? Well, what you end up doing is you end up identifying the different parts of what's going on in any article you're looking at. And then you treat each of these as a sort of sub-problem. And then in the course of your literature review, you will select the relevant ones and you'll dismiss those. You'll say, actually, that sub-problem in this article links to that sub-problem in a different article. So that's where I'm going to focus my mind, right? I'm going to see that there's a commonality. Both these articles talk about the same subject and attempt to solve it. So clearly they see a problem, right? And so what you find in this, and I know this is abstract and quite disconnected, so I don't want to make this too much longer, is that the more you break down a complex problem set into a number of different threads, and then you see the response, not necessarily dealing with all the threads. Some of the threads are ignored, some of the threads are cut out of the picture. That's something to watch for. And what you'll find, I mean, I come from a philosophical background, so it's very easy for me to spot, but nearly every solution, every response to a problem set, the reason that we haven't achieved, that's a stupid thing to say, but a kind of nirvana on the planet, right? That our tech hasn't solved all our problems or our ideas as a species haven't solved them, is because every defined problem set is by nature, it excludes and cuts out stuff. Right? This is a big issue for the history of science as well. No system of thought can include everything. So when people and scientists and computer engineers are defining a problem, they do two things. They exclude stuff, right? So watch for what's excluded, because when someone proposes a solution, you can apply this technique to anything, actually, even to politics. But when someone proposes a solution as a response to the problem set, and you think, wow, that's an amazing solution. Or, think really carefully. You want to think analytically, go back to the problem set and look for two things. What have they ignored, right? What have they deliberately cut out and said they can't deal with? That will show you what the limit of their definition of the problem is. So if you're analyzing it and you want to really dig into it, you say, actually, although the solution is an interesting one, it relates to blah, 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 and you talk about that, you might also want to say the way they define the problem is based on excluding a whole bunch of stuff which you think are critical to the topic, right? Which you might find in another article, or they do another thing. They make assumptions. So these two elements of excluding stuff or making assumptions are absolutely critical when you are trying to analyze a problem set. I can tell you a really fun thing that I like to do, but I don't get that much chance to do it these days, is you listen to someone's argument, you go back to how they've defined the problem, and you start picking all the things they've cut out. Said, no, it's not relevant, that's not relevant. You listen to someone argue their point, right? It doesn't matter if it's in technology or not. You listen to someone argue and you'll notice that they'll use the word relevant a lot. And so what they do in the use of the word relevant is they'll cut stuff out, and that will help them create what looks like a really clear defined problem set. Then they propose a solution. So this works both with tech, this works both with analytical reasoning, it also works with all kinds of different territories. And then going back to them and saying, actually, you cutting that out means that your problem set is not really a properly defined problem set. So it's only a partial solution. And if you include one of the elements you've cut out, your solution collapses, for example, right? You find those types of patterns appear. Another element is in defining a problem set, right? The situation is the assumptions they make. These two things, what they exclude and the assumptions they make, are very, very closely related. And it can be quite a fun, well, if you're sort of as twisted as I am, to kind of watch for what their assumptions are and to try to pick them apart. Because what you'll find that early excellent analytical thinking and reasoning is a person, and it comes in the form of someone who can spot what's been cut out, ignored, and what's passed over, if you like, or left out, and what's being assumed, to define a problem set, to then define a solution as a response to that problem set. Okay, so it is hugely, for me, it's really interesting because that logic applies across politics, across everyday life, technology, all of it. But that's just because that's my research area, if you like. So I come back to, just to wrap up, the basic relationship of technology and human practices.